Hello, college math topics. I am not in class today. I have a meeting at Clark Lane. The goal for today is to practice using the Pythagorean theorem, and then next class we're going to have a quiz on the angles of a triangle, parallel lines, similar triangles, and Pythagorean theorem. So we'll do a couple examples. You'll get some practice afterwards, and then if I can get the review done by tomorrow, then you guys will also have the quiz review to get started. So, the Pythagorean theorem. I believe this will be a review for many of you. It states that the sum, so think addition, the sum of the squares of the lengths of the legs equal the square of the length of the hypotenuse. So the sum, so we're adding the square of the leg. So anytime you have a right triangle, you're going to have the right angle made by two lines. Those two lines that make the right angle are what we call the legs of the right triangle. The side that connects the two lines together is what we call the hypotenuse, and it's always the longest side. So it's always the largest side is what we call the hypotenuse. So it's always the largest side, and it's always right across from the 90-degree angle. So if this is the 90-degree angle, the side that's across the triangle is what we call the hypotenuse. And that's always the biggest side. So no matter how big or small the triangle is, no matter how stretched out it is, if you take the two legs, square them, and add them together, that is always equivalent to just taking the hypotenuse and squaring that. And this gives us the Pythagorean theorem. This theorem was made by Pythagoras, who was in this Pythagorean group of people that studied mathematics thousands of years ago, way in the BC era. So it's a very old theorem that's used often when trying to compute distance between 2 points. And we could talk more about it when I'm in class. But for now, I just want us to get practice applying the Pythagorean theorem to find missing side lengths of right triangles. So in this particular case, we're given a right triangle. We're given the length of the bottom is 4. The vertical line is 6, and this diagonal line we're trying to find the value of. Now, here's the 90-degree angle, so I have two legs here. I have the leg that's length 4 and the leg that's length 6, and we're trying to find the longest length, which is the hypotenuse. Or as Mr. Doble calls it, the hypotenudal. So, how can we find the length of the hypotenuse? Well, all the sides of a right triangle are related by this, and this only applies to right triangles, by the way. The Pythagorean theorem only applies to right triangles, just to be clear. So if it's a right triangle, the Pythagorean theorem applies. If it's a wrong triangle, it would not apply. So if I want to find the length of x, I have my legs 6 and 4. It doesn't matter whether I call A6 or B6, A4 or B4, but the hypotenuse is what I'm looking for in this particular case. So if I call one of the legs 6 and the other leg 4, then we get 6 squared plus 4 squared equals the hypotenuse squared, which in this case I'm going to call it x instead of c. Now 6 squared is not 12, despite popular belief. It's 6 times 6, which is 36. 4 squared is 16, and that equals x squared. From here, we can add 36 and 16, which is going to give me 52. Now to find out what x is, I know x squared is 52, but this length is certainly not 52. It's less than that. To find out what x is, we have to undo squaring, and the operation that undoes squaring is square rooting. So if I do that, I'll get x is the square root of 52, which is approximately, let's see here. If if I just type SQRT 52, it'll tell me it's about 7.2. So this is the approximate answer, the square 7.2, and x equals the square root of 52. This is the exact answer. So here we have the approximate, and this is the exact. And you can see both of these on the SAT when you guys take it this month. So either one of these could be an option. And so just be aware that sometimes you leave in the square root. Sometimes you can just get a decimal approximation. Either one is fine. Okay. Um, Next problem. Find the value of x again, round to the nearest hundreds place. So again, I'm given a right triangle, so the Pythagorean theorem applies. The Pythagorean theorem, again, is the relationship between the three sides of a right triangle. So here's my right angle. The two sides touching my right angle are the two legs. So we can call these A and B. And the side that connects those two legs is what we call the hypotenuse. So in this case, if I call A 5, this becomes 5 squared. B is x minus 1. We got to square that. B squared equals C squared, which again, in this case, they're calling it x. Now, to save a little bit of time, we could solve this algebraically, but it's going to be easier to use Desmos for these, and especially because on the SAT, they're going to allow us to use that. Maybe it's better that we see if we can just use Desmos and save a little bit of time. If I just type 5 squared plus x minus 1 squared equals x squared, as long as we're using x, we can get a solution here. The solution happens to be 13. So without having to do any algebra, we can get x equals 13, no problem. All right. If we didn't do that, then I'd have to do 5 squared, which is 25. X minus 1 squared is x minus 1 times x minus 1. And then we have to do the distributive property. Some of you guys probably did this thing with boxes in algebra too. X times x is x squared. X times negative 1 is negative 1x. You also have to distribute the negative 1, so negative 1 times x also gives me negative 1x, and negative 1 times negative 1 is going to give me a positive 1. And then x squared is just whatever x squared is. So now I just rewrote this equation down here. If I subtract x squared on both sides, those are going to cancel out. Negative x minus x is negative 2x. And x squared minus x squared is 0. 25 plus 1 is 26. Oh, before I do that, let me add 2x to both sides to get the x on the other side. 25 plus 1 is 26. So 26 equals 2x. If you divide both sides by 2, you get x equals 13. So we can still get it that way. But again, use Desmos if that's available to you. What I did, this x minus 1 squared thing, I think in Algebra 2, you guys did something like this. If this looks familiar to you, x times x is x squared. X times negative 1 is negative 1x. X times negative 1 is also negative 1x, and negative 1 times negative 1 is positive 1. So you still get that x squared. Combine the like terms. And you'll still get that same expression that we got before. So anyways, use Desmos if you want, because it's going to save you a little bit of time. But you don't have to. Last example, we use the Pythagorean theorem again. This time, my two sides that make the right angle, one of them is the missing side. So I'm looking for one of the missing legs. And I actually know the hypotenuse in this case. So knowing that C is 15, my answer should be less than 15. So the relationship between the three sides of a right triangle is, if we take the sum of the square of the legs, a squared plus b squared, that's going to always add up to the square of the hypotenuse. So in this case, I'm going to replace a with x, b with 12, and c with 15. We can use Desmos here if you want to make it quick. X squared plus 12 squared equals 15 squared. And the solution right there is 9. Negative 9 would be a solution, but if we're talking about the lengths of a side, we can't have a negative number. So x equals 9 is the solution. And without Desmos, we can still get that, because 12 squared is 144. And 15 squared is 225. If you subtract 144 from both sides, 225 minus 144 is 81. And if you square root 81, you get 9. So either way you can get it, whether it's algebraically or Desmos, but it's a good strategy to have. So in class, what I'd like you guys to do is just work on finding the missing values indicated for each question. If you answer them, it'll also answer a question on this riddle. You only need to do the front side. You won't need to do the back side, at least not right now. So we'll pass that out, and then if I can get that study guide done, I'll also hopefully pass that out. Anyways, have a good day. If you like the video and want to see more, make sure you subscribe, ring that bell for notifications, and smash the like button. Au revoir.